Hello there, Year 10 mathematicians, Mr. Herman here, and this will be Lesson 2, Negative Indices, Exercise 3F from the Index Laws topic. The learning goal for this one is to understand how a negative power relates to division, and to know how to rewrite expressions involving negative and positive indices. The success criteria is to use index notation with numbers to establish the index laws with positive integral indices and the zero index. And we also are going to be able to apply index laws to numerical expressions with integer indices. So as a lesson starter, I've got this taken straight from the textbook, which looks at the disappearing bank balance. And the context goes like this. Due to fees, we have an initial bank balance of $64 and it's halved every month. Now we know how to halve an amount every time. Just keep dividing it by 2, divide by 2. And over each month, you'll see that when it gets to 1, when we halve 1, it turns into a half or 50 cents. And then we halve it again, it turns to a quarter or 25 cents. And we got half it again. And we can keep doing this. Half that is 1/16, half that 1/32, etc. But what I care about is the notation. So the positive indices only, what this means is if we want to write this in the form of a positive power. So right now we have 2 to the power 6, 2 to the power 5. This one, you can see the trend, it'll be 2 to the power 4. Sorry, my laptop just glitched up. 2 to the power of 4, or 2 times 2 times 2 times 2. 2 to the power 3, 2 to the power 2, 2 to the power 1. And then this will be 2 to the power 0. Remember, any number or letter to the power 0 will always equal 1. And just to prove that, here is this trend. Then we get to something here. Now, if the trend is showing this, that it's going down by 1, we should technically write this as 2 to the power of -1, which we can see here. In fact, let's do the same over here. 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. Then it goes 2 to the power of -1, 2 to the power of -2, and 2 to the power of -3. So this trend just keeps going by taking 1 from the power. This is what we call positive and negative indices, because we have positives up the top here, but then the negative starts happening as we go below the 0 power. But then if we want to use it as positive indices only, and here's a clue, it will be written as 1 over 2 to the power 1, 1 over 2 to the power 2, and 1 over 2 to the power of 3. And you can see that here, 1 over 2 is the same as 1 over 2 to the power 1. It makes sense, 2 to the power 1 is 2. 1 over 4 is also the same as 1 over 2 to the power 2. 1 over 8, 1 over 2 to the power 3. So you can see here, this format doesn't necessarily have negatives within the power. It's written in fraction format, but there are no negatives. No negatives. But this here, and specifically these 3 here, there are negatives within the power. So there are negatives within the power. And the types of questions you'll get will ask you to try to show no negatives within the context of indices, and only writing positive indices. And that's the skill we're going to be looking into today. So just as a side note, any number to the power of a negative that number can also be written as 1 over that same notation here, just without the negative. So this example from the previous one, 2 to the power of -3 is literally the same as 1 over 2 to the power of 3. And we know 2 to the power of 3 is just 2 times 2 times 2, which is 1 over 8. And conversely, the opposite of that, when we have 1 over 8 to the negative m, that is the same thing as just writing a to the power of m, okay? So for example, 1 over 2 to the power of -3, generally if you see a negative and it's on the bottom of the fraction, you take that negative away and you put it back onto the top, which is what they do into this step here. And again, we know 2 to the power 3 is equal to 8. So let's have a crack at these examples here. Express each of the following using positive indices. So b to the power of -4, and that's just the same as writing 1 over b to the power of 4. So we got rid of that negative because we're using positive indices just by putting that b to the bottom and taking away that negative, making sure we put that 4 there as a power. The next one, 3 times x to the power of -4 times y to the power of 2. The 3 is a positive, so we keep it on top. The y squared is a positive, so we keep that on top. But then what goes into the bottom is the x to the power of -4. That actually just stays as x to the power of 4. We take away that negative, but as a result, we put it into the bottom. And that's all there is to it. So we're just applying rules from the key ideas. One way is just showing it with negatives. One way is showing it with positives, not really necessarily solving for anything. And then the last one, because we have this negative power and it's also onto the bottom, we have to put it onto the top with that 5. And then as a result, get rid of that negative. Okay. All right, we're going to get into some a bit more complicated examples. Simplify the following expressing answers using positive indices. So again, we're going with the positive indices format. Here we have 2, and then we've got letters A and letters B and associated numbers. Now remember, if there's a division of some sort, you subtract the powers with the same base. So in this case, 2, A to the power of 3, and because it's a division, it'll be 3 take away 5. So 3 take away 5 with the same base. And in this case, this will be B2 take away 3. Okay, so I haven't necessarily worked out anything yet. We've just put it into this format where we can work it out. A to the power of 3 take away 5 is this A to the power of -2. So 3 take away 5 is -2. And B2 to the power, B to the power of 2 take away 3 is 2 take away 3 is -1. Now both of these are negatives and they're on the top, so we're just going to put them on the bottom, a squared, and b to the power 1 we can just leave as that. And that's all there is to it, okay? So a lot of these rules seem pretty new and a bit daunting at first, but as long as you apply the same rules, it's easy to get the hang of. This one, again, we've just got 2 different letters, M and N, but we've also got this 4 over 8. Now, if you paid attention to the previous example, 4 over 8 can be simplified down to a half. All right, so that's the number component part to it, really nice and simple. So we've got the half 1, and we've got M to the power of -2. Now we've got -2 and a 5, so remember there's a division, so we're just going to take away 5. And then we've got this N3 takeaway. Now we're doing 3 takeaway, but then we've also got this -4. So that turns into -4 there. And when we have 2 negatives put together, this technically turns into a positive, a plus. So you've got to be careful with this notation here. But 2 negatives put together, it turns into a plus, and that makes sense. If we were to take this n to the power of -4 and put it onto the top, it would just be n to the power of 4. And n times 3, n to the power of 3 times n to the power of 4 would be n to the power of 7, which is what we're technically doing here. 3 plus 4 is equal to 7. Now remember, we've also got this simplified 8 that has a 2 on the bottom there, so we just got to be careful or mindful of that. Now that 1 is not necessarily needed, so we can just leave it for now. M to the power of -2 take away 5 is M to the power of -7. So -2 take 5 is -7. And N3 plus 4 is +7. All of this over 2. Now lastly, we've got this negative on the top. We don't like this, so we're going to keep the N to the power of 7 on the top. And 2 times M to the 7. We're going to put that negative back to the bottom here. Now again, a lot of these rules do seem quite confusing. I'm just sticking to those same index laws, either adding or subtracting the powers depending on whether they're being multiplied or divided by. And if I see negatives, I put them on the bottom. Unless there's a negative already on the bottom, I'll put them to the top. That's all I'm doing, with the added rule of simplifying, of course. Now, we're going to get into trickier examples, okay? And if you are quite unfamiliar or unsure with this approach and it seems a bit daunting, I don't blame you, okay? Looking at this type of question can seem rather intimidating, okay? But again, all I'm doing is I'm going to be applying specific rules and index laws in order to simplify this, because that's what we're doing at the end of the day. We're simplifying and we're showing this in a positive format, okay? If you're good with just following rules and following steps, this will be a piece of cake, okay? So the first thing we need to do is we have these brackets around these letters here, and there's a 4. So remember, when there's a 4 on the outside as a power on the outside of that bracket, it gets multiplied to everything on the inside. So P to the power of -2 multiplied by 4 will be P to the power of -8. And that Q, there's technically a 1 on that as a power, that will just be Q to the power of 4. Okay, so we've got rid of those brackets, but as a result, the 4 gets applied to both of those powers. And nothing's necessarily happening on the bottom, so we can just write that as is. Q3. And we're multiplying this by, now again, that -3 is around both the top and the bottom. So that -3 gets applied to this power and to this power, okay? So P times -2 times -3, when you multiply two negative numbers together, it makes a positive. So that would be P to the power of +6. And Q to the power of 3 times -3 will be Q to the power of -9. Because 3 times 3 is 9. So I haven't necessarily done anything new. I've just applied basic multiplication. It's just knowing what to apply that multiplication to is the tricky part. All right, the next thing we're going to do is we're going to tidy up everything we're seeing on the top by itself first. So all of this here, and then we're also simultaneously going to apply everything to here for the bottom part, okay? Remember, we've got this time, so when we're timesing it, we're just adding any powers together, provided that the bases are the same. So in this case here, we've got a P -8 and a P6. So in this case, we have -8 plus 6. So this will be P to the power of -2. All right, so we've got P to the power of -2, -8 plus 6 is -2. Then we have just that Q4 by itself. There's no other Q's on the top part, so we just leave it as is. Second part, we've got that 5 lingering there. Any P's associated? No, so we just leave it as P -1. All right, now we have Q3. Remember that times is also being applied to the bottom as well. Q3 plus -9. So 3 plus -9, a plus and a minus turns into a minus. So 3 minus 9 gives me -6. All right, now let's do a little bit more tidy up. We have got P to the power of -2, and now we have a division, so we're going to take away another 1. So this is going to be P -2 take away -1. Two negatives turn into a positive, so it would just be -2 plus 1, and we'll work that out in the next step. And this will be Q4 minus -6. Again, two negatives turn into a positive, and that will be all over 5. All right, we can work this out straight away. I'll put the answer up here. I might have to erase this so we have enough room for this one here. Okay, we have -2 plus 1 will become -1. So that will be P to the power of -1, which I could just put as a bottom, P to the power of 1. And then we've got Q4 plus 6, so that's 10. So that Q to the power of 10 will stay on the top, it's not a negative. And we also got that 5, and that's still on the bottom. So that will be our final answer. Now, if you're looking at this and you're thinking, what in the heck is going on? I recommend that you re-watch this again and understand where these steps are coming from and why I'm doing them, okay? There is a reason behind each step as they go along. And we'll tackle this last question and I'll get you to do exercise 3F. Okay, last one. I had to erase everything from this question because I needed a bit of room. Here we've got powers with brackets and powers with brackets. The very first thing I do is I associate that power 3 to every single term, both on the top and on the bottom. So here, this will turn into a 2 to the power 3. So that 3 is getting applied to that. And I already know that actually, I'm gonna erase that. I already know that 2 to the power 3 is 8. 2 times 2 is 4, times 2 is 8. So I'm just write 8 straight away. We have an m to the power of 9, as 3 times 3 is 9. This is going to be all over r to the power 6, and n to the power of negative 12. Again, that 3 is being applied to that, and to that power there. 2 times 3 is 6, negative 4 times 3 is 12. We have a divided by. Now we're going to apply that 2 to the power of every single term in here. 5 to the power of 2 is 5 times 5, which is 25. M to the power of negative 2 times positive 2 will be m to the power of negative 4. N to the power of negative 3 times 2, n to the power of 6, all over r to the power of 2. Okay. I'm now going to rely on a year 7 or year 8 skill called keep, change, flip. Okay, keep, change, flip has to do with fractions, and specifically when dividing fractions. Now this divided by this is a bit tricky to digest, okay? And so what I'm going to do is I'm going to change this to a multiplication sign, okay? Because this here, when there was a multiplication, it was easy for us to work out. But when we have a division, it gets a bit tricky. So I'm going to apply keep, change, flip. Keep stands for keep the first term as it is. So this fraction here, we're going to keep it as it is. The C stands for change, meaning I'm going to change that division sign into a multiplication sign. So it looks like this. And then flip means the second fraction here, I'm going to flip it upside down. Okay, so these two different equations technically mean the same thing, they're just written in a different format. Okay, and we're technically allowed to do this, provided that we just don't simply change it to a multiplication sign. And if we do, as a result, the second term flips around. Not the first term, the first fraction, we keep that as is. The second one flips around. Now we can go ahead and push everything together that we know should be together. So up the top, we're going to do all of these together. It's been times. None of them are the same, so we can just leave them as that. No bases are the same, to be specific. Any R's that are there? No. So I'll put the 25 at the start because there's 25 here. Nope, R6, we'll leave it as that. N's, yep, okay, so we've got a negative 12 and we're adding, because there's a multiplication, negative 12 plus 6. So this will be n to the power of negative 6. So negative 12 plus 6 is negative 6. And the m to the negative 4 stays the same. Okay, nearly there. We are going to put that 8 there, m to the power of 9. And there's another one here. We're going to have a division, so we're going to take away negative 4, 2 negatives, make a positive. We'll work that out next line. We have a R2, take away 6, and we also have this n to the power of negative 6 on the bottom, so we can just put that to the top like this, and that will be all over 25. All right, 9 plus 4 is 13, so this will be m to the power of 14. Rn 2 minus 6 2 minus 6 is negative 4, so we know that's going to go into the bottom. So we'll leave it as n to the power 6, and at 25, r to the power of 4. So remember, r to the power of 2 minus 6 is 4, negative 4. And because it's negative on the top, we have to put it onto the bottom. So it's r to the power of 4. And that should be your final solution. Now just realize that this 14 should be a 13. Apologies. Because 9 plus 4 is 13, not 14. I read that as a 10 because I'm silly. But this is your final answer. Now, yes, very intimidating. A lot of steps involved, a lot of rules. If you find these type of questions intimidating, by all means, attempt it, but don't get too discouraged if you don't get the correct answer, okay? My main focus, and I did these tricky examples for those who want to accept a challenge, but my main focus is for you to be able to do these type of questions. And these type of questions look simple now in comparison, don't they? All right, go ahead and attempt the questions from exercise 3F, and I'll see you guys in the next video. Bye-bye.